Now we're going to get into geometrical transformations. I think this is one of the more funner units. If you're a visual learner, kind of hands-on, you should be okay in this unit. The first lesson is going to cover the different types of rigid transformations, so translations, reflections, and rotations. Then we'll have a quiz. Lesson 2 we'll cover non-rigid, which is basically just dilations. After that, we'll have a quiz. Then we'll do composite transformations for lesson 3, have a quiz, and take a test on it. All right, so getting right into it. Rigid transformation is a movement that alters the location of an object, but not the size. Okay, so if you want to think about moving a chair across the room, you can slide it, you can flip it, you can, spin it, but the chair is still the same size. Okay, so the pre-image is the location of an object before being moved, where the image is the location after being moved. Noted with a little tick mark most of the time. It can also be called a prime. All right, so the one we're going to look at today is probably the easiest, and it's translations. Okay, so translations are slides, shifts. Okay, these are the two main keywords that you'll see. The slide and shift types are going to be up and down, so vertical, or left, right, which is horizontal. Now, going off this just a little bit more, vertically shifted is going to be related to our Y values. Horizontally shifted is going to be related to our X values. Notation can be one or two ways. So it can say, given the point XY, move it to X plus or minus blah. Whoops. And then Y plus or minus blah, where the blanks is by what value. If you add, so if I'm adding on a number line, I'm going to the right. If I'm subtracting, I'm going to the left. And then Y plus, when I'm adding, I increase in value. When I'm subtracting, I decrease in value. Okay. Shorthand notation is going to be T, parentheses, X, Y. And then I'm just going to say point. Okay. And I actually make a map here really quick. Yeah, I got plenty of room. Where I have this thing T, and then X, Y attached to it, and then I have the point. And then T, X, Y can be broken down into a couple other things. T, and then X, Y. Where T tells you transformation or translation, and then XY is just by how much. And then P, or your point or your figure, It's just going to be what is being moved. All right. So what I like to do is run through these. Again, I want to identify translations, so slides or shifts. And if you look here, I don't give you just points. I give you entire figures. The reason they do this is because the more you have to move, the more likely you are to get something wrong. Okay? So if I think about just point to point, point to point, point to point, I'm going to find the transformation that occurred from one point to another, go check my answer choices. If it doesn't have the transformation that I found, then I'm going to mark it off, and I'm going to go to the next answer choice and so on. Now, so starting off here, I see translated, so that lets me know I want to actually do this one because we just talked about it. A, B, C, D was moved to A, B, C, D prime. Now, something that's pretty cool about these is that all of your points are going to go together. So A is going to go to A prime, B to B prime, C to C prime, and then D to D prime. So A to A prime. What you do here is actually just plot points, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7. So I went from 10, 7 to 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So if I go from 10-7 to 3-7, I'm just going to go left 7, and then Y value doesn't move, okay? So you could write this as translation, the point X minus 7, and then Y of figure A, B, C, D. Okay, because when I take the original X value 10, subtract 7, I get 3. When I take the original Y value 7, I don't do anything to it. I still finish up with 7. Okay, and then you can try and find the rules for B, C, and D. If you take the time to do it, you'll find something that's pretty interesting about it. So maybe I need to erase B, C, and D because we didn't actually do those. Rotation, no, doesn't tell me. Translated, okay. So translated, which of the characteristics are the same? So again, translations are rigid movements. So anything involving side is going to stay the same. And then area, right? Because area is dependent upon the side lengths. Coordinates. The entire purpose of transformations is to change coordinates. All right, so 1 and 2. Reflect, rotate. Okay. What I want you to do is number 7, 8, 5, or 6, whichever of these involves translations, and then upload your answer to Canvas. If you can do 1 point, that's all I need you to do. So, for example, if this one winds up, if you don't have points, it's okay to label them. So A, B, C, and D, right? Nothing's wrong with that. So if this one happens to be translated, you can go from A and then just tell me where the coordinate would be at. Same thing here. I only need 1 point. If you can do 1 point, that lets me know that you could do it to 2 points, 3 points, 4 points, or 5 points.